Students, welcome to NSCI120. This is a class for non-science majors, and we are going to be doing lots of labs and also assignments. This first assignment is for you to get to know your lab partners. So if you must work alone, okay, you can, but there are 12 labs. And if you work with partners, it's going to be a lot better for you. And we're going to do an exercise later in this first lab to show you how valuable lab partners are. So the first thing you're going to do is, I've got this page uploaded, and you are going to get to know your lab partners. Now you can work in groups of 2, 3, 4, maximum of 5, okay? Of course, if you have only 2, then you're only going to have 2 of these filled out. If you have 5, you got to stick a 5th one somewhere. This is just getting to know your lab partners. So this is your first assignment. And so what you're going to do is, on the outside, you're going to put your name, and then 2 unique things about you. You know, I was born in wherever, or just something unique about you. So you're going to have to do some discussing. Do FaceTime or Google Meets, or you can go in the Zoom room together. I've got a Zoom room dedicated to this course, which is available to you 24/7. So you can text me and say, hey, I need some help with this, or you can text the lab teacher. And if we're available, we can go in the Zoom room. You can use this for group work with your lab people, or you can do your group work on, you know, a different mode if you like. Anyways, on the outside, everyone's going to put their name and then 2 unique things about them. In the middle, you're going to put 2 things that you have in common. And it can't be that we're signed up for NSCI120, because I already know that. Okay, so maybe you all have a sister, maybe you all have a dog, maybe you all have a kid, whatever. So you need to find 2 things. So this is a real nice, easy assignment, but you're going to get to know your lab partners, because getting to know your lab partners is really important in this class. And also, we're going to be doing some peer reviews. So you will also be able to let me know if there's, you know, someone in your group that's not pulling their own weight or things like that. Okay, so this is your first assignment. Now, the next thing you're going to do, I'm going to put this up onto the screen, and I'll take this out. Okay. The next thing you're going to do is, you're going to see just how valuable your lab partners are. And so this box is a puzzle, and I'm just showing you, you don't need to necessarily make this same box, which I have the template for right here. Okay, and that will also be online. Okay. You don't necessarily have to have, you know, this exact little cube. You can just use any little box that you have and label them. Okay? So this is a puzzle, and on each edge of the box, there's a name, there's a number, and there's another number. So there's 2 different numbers. What you need to do is solve the puzzle for the name that would go on this bottom, which is blank. Okay? This is blank. So, Frank 54, those numbers mean something. You need to find the name that goes along with Frank. Let me show you how this works. And I'll just spin these. And each person in the group should only look at one edge. So you're going to make this box. You're going to have each edge of the box have a different number, set of numbers on it. Use these numbers. This is the blank one that's on the opposite side of Frank. Okay, this is the one you need to solve for. Okay. We've got Roberta 7 and 3. So we've got Alma and Albert. So in other words, this square is a puzzle. You need to find the name that would be opposite of Frank. And you also need to find the numbers. You can try and solve this yourself, but if you work together, if each person in the group takes one side of the cube, and everyone can see the top, 5 and 4, one person can see Albert, 6, 2, and the other person can see Elma, 4, 2. And what you do is solve for the puzzle. That's the second part of this lab. Collaboration in science is what science is all about today. Solving the coronavirus, getting that vaccine as fast as we got it, was all because of collaboration. When the scientists in China figured out the exact genetic code, they gave it to any scientists that were working on these type of viruses. Those scientists were able to take that exact genetic code and make a protein that would disable that genetic code. And that's why we came up with a vaccine so fast, because scientists collaborate. Back in the day, scientists were always trying to outdo each other and beat each other and compete with each other. In fact, right here on campus, we have a secret laboratory that that Henry Ford put into his mansion, into the powerhouse. It had no windows. It was only accessible by an elevator, very secret, where he worked on his latest, models and cars and, designs and so on. Even the automakers today are collaborating like crazy to get that electric battery that's going to work for our, driving needs. Even in industry, collaboration is huge. With the vaccines, we have Merck helping out Johnson & Johnson. So collaboration is a huge thing, and in this lab, if you collaborate, if you work with your lab partners, you're going to have a much better experience. It's going to work out much better for you. So that's kind of what this puzzle is about. You can try and solve it yourself. If you are working alone, maybe you can use some roommates or family members to help you solve it. But you'll see that each lab partner contributes a little bit to the puzzle, and in the end, you'll solve it a lot easier if you collaborate. Okay? So collaboration is huge. Okay, the next thing we're going to do is we're going to make a special little loop. And what you need to do is just take any long skinny paper that you have, okay? And you're going to make a loop with it. And this loop has an inside, and this loop has an outside. Those are not connected, okay? There's a separate inside. There's 2 dimensions to this loop. Now, what you're going to do next is you're going to take one of the ends and you're going to twist it so that you get a little twist in this loop, and then you're going to tape it. Okay. Then you're going to tape it. Okay. So now you've got this loop that has a little twist in it. Remember, you just simply take the paper, you bring it like this. This is getting near the end of the roll. Let me get a newer roll so it's not. And as I thought of that, I just thought, oh, you could use toilet paper for this. You don't have to have register tape. Okay, You can use toilet paper for this. You make a loop, okay? This loop has an inside, and this loop has an outside, okay? Now, when you put this little twist in it, you completely change what's happening here. Okay, we've made a little twist. And you tape the ends, okay? Now you've got this interesting piece. And what you're going to do next is you're going to take a pencil or some writing instrument, and you're going to just draw a line around this loop. So I like to kind of just hold the pencil, and you're going to go right down the middle, and you're going to keep pulling and keep pulling. Okay, and this is all twisted up. Keep pulling. I'm going right down the middle. Not exactly down the middle, but I'm trying my best. Okay. I'm going to make a line right down the middle. And now, using the black marker was not the best idea because it's bleeding through, but you're getting the idea. You're going to keep going until you come back to where you started. Just hold your pencil down, pull your loop through. This is getting all tangled up. La, la, la. I'm almost back to where I started from. Here's where I started from. I should have made an X there. Now, there's something very special about this loop. Okay? This loop does not have an inside or an outside. If you had this ant, an ant walk along this path, they would walk along a single path. They would end up right where they started, but this has no inside or outside. This special loop was thought of, or the person who discovered it was named Möbius. Okay, I say Möbius because it's German and that umlaut over the O. Okay, this is called a Möbius strip, and this is a very special circle. Okay, now, if you've ever noticed some of the bands in your car, like some of the belts that are in your car, some of those have a turn in them. If you think about it, if you have a belt in your car that has an inside and an outside, what is friction going to do as that inside rubs against whatever, whatever is that belt is going around? Same thing with like escalators. They work with belts as well. If you don't have a twist in that belt, there's an inside that gets all the rubbing, and that thing lasts half as long as a belt that has a twist, because now there's no inside or outside, and this belt with one little twist will last twice as long as one that is like so. That's all water on the bridge. Now, what you need to do is, as a group, you are going to make predictions. Okay? You're going to make predictions that if I take scissors and I cut along this line, what will be the result? Okay? So, you are going to make predictions. And I want at least 3 predictions on this lab. If I cut down this line what do you think the result will be? What do you think will be the result? Okay. Will I end up with one big ring? Will I end up with two little rings? Will I end up with, what will I end up with? I want you to make 3 predictions. Then I want you to actually carry out the experiment, okay, and make that cut. All right? I want you to show me, you're going to show me a picture of what happened. That's part of the lab, showing me a picture. So just insert the picture. What you can do with these Google Docs is you just make a copy of the lab as it is, and then you're going to add pictures or add your various answers and so on, rename it, and then you submit it to Canvas. It's very simple. So on the lab or the file, the Google Doc or the Word doc, and by the way, if you don't have Word, the university provides it for free. We have a lot of free software. Make sure you take advantage of it. I'll put the link in announcements in case you don't have Word. But with the lab, you're just going to fill in. You're going to put your 3 predictions. You're going to put a picture of what happened when you actually did the experiment. Once you end up with whatever you end up with, I want you to again predict what would happen if I cut again and show me that result as well. Okay? So you're not only going to cut this, predict what would happen if you cut all the way along this line. Once you get whatever result you get, you're going to make a prediction again about what you would get if you cut that. It's going to be a little bit thinner, okay, when you cut the next time. What would happen? So this is part of science called, making predictions and testing your predictions. So scientists observe things. Scientists think about things. They make predictions, and they carry out experiments, and oftentimes during their experiments they end up with more questions than they started with. You're going to see when you actually carry this out. Probably you'll get a result that's completely different than what you thought. Okay? Rarely do students actually predict the actual outcome. Very few people have that spatial ability to just think about how this would end up if I cut it all the way around. All right, so that's the next part of your lab. So far, so good, right? So far, no big deal. Now, the next part of your lab, you're going to be making a dichotomous key, okay? So I'll actually have those instructions. I'll actually have it written out, and you're going to actually key something out. And we'll do that again later in a lab later in the semester, okay? We'll actually key those. We'll actually do that a little bit later. Okay, the last thing is, again, something that you're going to need to collaborate greatly in order to figure this one out. So right now I have 2, 4, 6, I have 7 white powders, and I have 7 different chemicals that I am going to be using, and I'm going to put my goggles on. Okay, anytime we're working with chemicals, we'll have our goggles on. Each of these different chemicals, and I have them spelled out here on the board, okay, what they are. We're going to use these different chemicals. We're going to put them onto each of these powders. And what you need to figure out is that 2 of these powders are the same thing. They're all white powders, but 2 of them are the same substance. Okay? 2 of them are the same substance. And you need to figure out which 2 are the same based on the results from the reactions that we're going to do with these different reagents, with iodine, silver nitrate, hydrochloric acid, iron chloride, barium chloride, cobalt nitrate, and copper chloride. So each of these will be added to the white powder. You're going to look at the results and determine which letters are the same substance. Okay? Don't go by what they look like, because one might be chunky and one might be ground up, but they could be the same substance. Go by what reaction we get with these various reagents. We are going to now add the chemicals to our white powders. Now remember, don't judge by how they look, because we may have ground one up and kept one chunky and lots of different things. You're going to judge by how they react with the various chemicals that we're going to add. What we are looking for is two that are the same. Okay, two of these are the same. And I'm not going to tell you which two. So we will start with the iodine, okay, Lugol's solution. And this is a orangish brown solution. Now if I add an orangish brown solution to a white powder and it gets a little bit lighter orangish brown, is that significant? What do you think? Has there been a chemical reaction? No. So let's see in this first one. That looks orangish brown. Now we're going to go to B. So I'm just going to go right down the line to C, to D. That is the color of the solution. So there is nothing going on so far. To E, to F, and to G. Okay, so we did see a reaction. When you take an orange-brown chemical and you add it to a white powder and it turns bright blue, that's significant. Now, did any of the others turn that color? So do you think that's the one that has a match or partner? So we'll set the Lugol's aside. Now, the next chemical we're going to use is silver nitrate. Okay, this is a clear solution. We're going to add it to, oh, it turns kind of a yellowish color. Oh, that's kind of turns into some kind of chalky. Okay. We've got a little chalkiness there. We've got, oh, that's fizzing. Can you hear the fizzing? And it's yellow. So, whoops. And this last one. All right, there goes the silver nitrate. So we've got some possibilities. You know, these two have done the same thing. A few of the other ones have done the same thing. And now we're going to do the hydrochloric acid. We're going to do A. That's turning a little bit pinkish. C. There's D. E. Now that's really fizzing. Okay. All right. Next is the iron chloride. Now again, this is kind of a light brown color. So we will see. Now that almost looks like it got a little darker. Let's see. Wow. Okay. That turned blood red. Okay. That one almost looks like it got a little darker. That one's fizzing again. Okay. All right, 3 more to go. Next we have the barium chloride. And let's try A. And B. And C. Barium chloride so far turning out to be quite the dud. F. Okay, it's barium chloride was no fun, was it? Okay, cobalt chloride is our next one. So we've almost got all our data. Okay, now this is kind of a light pinkish to start. Okay, now that kind of turned a purplish color. This is actually the color of the liquid. So sometimes results are significant and sometimes they are not. Like if you take a light pink and put it with a white powder and it's a little lighter pink, you know, did something happen there? This one looks like it's turning a darker pink. Let's see about this one. Okay, we've got one more. And maybe you have some guesses right now, but maybe this will confirm your guess. Oh, that turned like a brownish color. That also turned a brownish color. This is a light blue liquid. So it is, that's the color of the liquid. Okay, that light blue. So we know these didn't react, but these did react because we get something completely different. So there's 4 ways we can tell that there's a reaction. We can see bubbling, which we saw some bubbling. We can see a color change. We can see a precipitate forming, which in our next lab, or in our Elemental 1 lab, you'll see when you take 2 liquids and a solid forms. That's called a precipitate. So we've got the bubbling, the color change, the precipitate, and then we can have heat or cool. We can have an exothermic or endothermic reaction where heat is given off or heat is absorbed. So those are the ways. So 2 of these are the same. They're the same substance, and there have been, you know, as time's gone on, some of what the initial reaction was has kind of calmed down a bit. So you might need to rewind and confirm your results. But I think you'll be able to figure out which 2 are the same. And actually, as a class, you can have a little discussion in Zoom, or you can put up a little chat in Zoom to verify what people think. Remember, go back to when they were reacting if you have any questions, because it might not be quite as obvious right at this moment. All right, that's all I'm going to say about that.